Please welcome Dr. Andrew Baker.
Well, hello and good evening. I'm honored to be able to talk to you today about our efforts to build climate-resilient reefs in Florida and around the world. The University of Miami's Rosenstiel School, as many of you know, has a long history of coral reef research. And in fact, it was founded all the way back in 1943 by a young British marine biologist with a passion for coral reefs, Dr. F.G. Walton Smith. And shortly after founding the school, Walton Smith published Atlantic Reef Corals, which at the time was an authoritative scientific guide to the identification and natural history of these amazing animals. But much of the reason why the school was founded is that Miami is located in the northern end of the largest barrier reef ecosystem in the continental US, which makes it incredibly easy to do cutting-edge research to understand the marine life that lives in these spectacular and pristine rainforests of the sea. And now, over 75 years later, coral reef research is still one of UM's signature research strengths, but our motivations for this research are now very, very different. Instead of trying to understand the biology of these systems, we're racing against the clock to try to find ways to help these dying ecosystems survive continued climate change. Coral reefs are some of the most imperiled ecosystems in the world from the point of view of climate change, because temperatures cause corals to turn white in a process called coral bleaching. Heat stress causes them to pale. Healthy corals normally play host to millions of tiny symbiotic algae, and these tiny algae help corals use the energy of the sun to fuel their survival and growth. But high temperatures cause this partnership to break down, which causes the coral to turn white. We're now seeing almost yearly episodes of coral reef bleaching around the world. And just in the last 3 years, Australia's Great Barrier Reef has lost almost 50% of its corals. Closer to home, back-to-back episodes of coral bleaching have been occurring in Florida, in fact, right here in Miami-Dade. And these reefs have also been devastated by disease outbreaks that make the situation even more dire for these very biodiverse ecosystems. But in the face of these threats, the coral reef scientific community has realized that extraordinary measures are now needed to meet the scale of this challenge. We must take steps to intervene in order to give corals a fighting chance of surviving the next few decades of climate change, while we shift to a carbon-neutral economy or find other ways to solve the climate crisis. The US National Academy of Sciences recently convened a committee to review all the potential interventions that 21st century science might be able to bring to bear to help increase the ability of reef-building corals to withstand warming temperatures. As a member of that committee, I reviewed all of these potential research directions, and we made recommendations as to how to best develop and test these new strategies as part of an overall management plan to preserve and sustain coral reefs. So these interventions include population and community interventions, which are things like assisted migration, which is moving corals from warm reefs to cool reefs in anticipation of continued warming. They include physiological interventions, such as stress hardening, which is growing out corals in conditions that kind of toughen them up and make them better able to survive climate change. And they also include genetic and reproductive interventions, such as breeding corals for increased heat tolerance, recognizing that there are corals out there that already live in very warm conditions, and if we can breed corals from those populations with our local corals, we can produce offspring that can be used to seed our local reefs with new coral babies that are potentially more heat tolerant. And this direction even includes laboratory studies of transgenic corals and symbionts to see if we can engineer more heat-resistant corals at the genetic level. Finally, in some areas, like Australia, these proposed activities also include environmental interventions, such as marine cloud brightening, which is testing whether the artificial production of clouds offshore during the warmest summer months can reduce the heat load on the reefs and prevent coral bleaching. And I think these geoengineering proposals show just how far the coral reef science community has come in trying every possible avenue to try to help these ecosystems survive. The University of Miami is taking what I think is our rightful place in helping lead efforts to develop, test, and deploy all of these scientific interventions. Because what these interventions all have in common is that they need state-of-the-science facilities and laboratories close to reefs where the techniques can be developed and tested as quickly as possible, which of course is exactly what we have here in Miami. And in fact, we must protect these systems as part of our own survival strategy. Research that was published just a few months ago shows that healthy reefs in Southeast Florida are worth hundreds of millions of dollars a year just for the role they play in protecting our coastlines from the potentially devastating impacts of storm surge and coastal flooding. And so here at as part of the new University of Miami Laboratory for Integrative Knowledge, or ULINK, we're also studying the value of reefs in reducing wave energy using a unique facility that's capable of generating Category 5 hurricane force winds and waves that can directly measure for the first time how to best restore reefs to get the most coastline protection in the most cost-effective and timely way. And at the same time, we're also using these restoration opportunities to test our intervention strategies so that these restoration efforts not only build coastal resilience, but are themselves also climate resilient. And so, in some ways, the University of Miami's Rosenstiel School has kind of come full circle from being founded to help study these beautiful reef ecosystems to helping the urgent scientific mission to discover new ways to protect them in an era of climate change. And we accept this challenge as part of the mantle of responsibility that our own history and geography has given us. And it's both a humbling and an exciting time for us. Humbling because coral reefs are on the brink of becoming the first major global ecosystem to disappear as a result of climate change, and there are no guarantees of success. But exciting because our efforts have the chance to make a difference to the real-world environment that our children are going to inherit. And we need to galvanize all of our efforts now to help ensure that they too can still marvel at these spectacular marine habitats and all the amazing life that they support. Thank you.